Your life.
Hey everyone, welcome to another Wolfram Institute Life Science stream. Today we're doing something kind of new, which is we're having a fellow research roundtable. So if you've seen our community fora, Wukash is laughing because there's only three of us, so it's not really a roundtable. It's more like it's like one of those triangular tables that you'd see in Clockwork Orange or something. So anyway, so it's we're yeah. So we're if you've seen our community fora in the past, we get together, we have a kind of informal conversation about questions that are sent to us. I thought we could have a similar kind of conversation, but instead of it addressing questions that we receive, it could be about things that we've been doing over the past week or so. Now, normally we'd have Richard, we'd have Carlos, etc. Richard is still sick, and Carlos is still Carlos was away and he's still traveling. He's still kind of traveling limbo, so it's fine. So okay, so it's the three of us again, and I thought we could start though with Łukasz had done some pretty interesting work this week. He did basically trying to visualize the Adels, and Łukasz could explain what the Adels are. If it's a this is something in number theory, but he started producing these animations that exhibit some strange behavior that we didn't expect to see. So I don't know. Why don't we start with that? I mean, Wukai, would you mind showing off a little bit?
Hey, you're trying to have a discussion, not a Langlands meeting. So maybe,
What's an Adele? Is it that singer, or what?
yeah, exactly. It's that singer. If you
Actually,
try to Google
I
Adele,
asked the
Adele
GPT.
Ring,
I asked the GPT, and it's like, It's not a singer. It's this term in numeric something theory. So it's actually like make this correction so that they're not mistaken. It's for a singer. It's kind of fun.
yeah. So
What are Adele's? Eh?
yeah, you have p-adic numbers, and p-adic numbers. I think I explained them a couple of times already, but you can basically think of them as, three-adic numbers.
No, what is the
Like,
relation again? What do you mean? What's the relationship between, for example, if I know what periodic numbers already are, what they are?
okay, so it's just a product, formal product for all the p's, for all the prime ideals in your ring, or just
Like
over
all the
integers,
primes.
all the prime numbers. Yeah, all the primes. So 2, 3, 5, so on, and one so-called infinite prime, which is real numbers.
It's just R times the product of Q sub P
Yeah,
for all P. So you take all Q sub P for all the p-adics. You take their product. You also product it with the reals. So it's all the completions of the rationals. Yeah, basically all the completions of the rational.
So
yeah.
is
If
it
you
like
know
a
Ostrovsky theorem.
type, like if I wanna instantiate this Adele number, I have to specify the infinite sequence of all the periodic numbers for every p,
Hmm.
right?
Yeah,
So that's what
and for
instantiate a
infinite
single one.
P1 real number.
Okay.
Yeah, yeah, basically, and there are some conditions like only like cofinitely many of them should be p-adic integers, so on, so on. Like finitely many non-integers. Yeah, but in p-adic numbers being like you don't have that many non-integers.
Integers would be
Okay.
the one that starts with infinite nines, something like that.
No, integers are actually like everything that doesn't have something after the comma. This is not an integer, but everything like that or like that is an integer.
Yeah, with no
Basically,
negative
and you can
powers.
only have finitely many terms after the comma. So
Okay.
I think you have countably many non-integers. So, like if you mod out by integers. Yeah. Okay.
What's the motivation for using the Adels, Lukash? Why take the product of all the completions of the rational?
You can translate some notions in number theory into like adelic setting. You have these Hecke characters, which are like complicated. At this point, I don't even remember the exact definition. It was a couple of months ago. But yeah, you have these Hecke characters, and they're like it is a somewhat complicated notion if you want to define it using like non-adelic number theoretic terms, let's say. But you can sort of push all this abstraction into the definition of Adels, and then it becomes if you're familiar with Adels, all these definitions become simpler.
Okay, and so
So
we've been
Adels, yeah,
okay,
Adels
go ahead.
capture like all like significant amount of abstraction that there is in different notions in number theory.
Is it
And
implemented in one of those mathematical languages or packages like Sage or whatever?
Yeah, probably you have some functionality in Sage.
but in our case, we're finding, I mean, technically Mathematica is a it should be in the same class, but we're finding that there are many kind of objects and things in pure math that that we don't have in Mathematica, that we kind of we're kind of forced to invent from scratch. Even basic things like a ring theory, um,
Oh, if it
we don't actually have.
would have called pure Mathematica, then I would agree. But that's like too much to ask for a language to have.
What was I going to say? So, yeah, the Adels are also helpful. I don't know if people remember our conversations previously about class field theory. There's a way to kind of generalize class field theory to the Adels. You can also take representations of the Adels, or these cuspidal automorphic representations. So, yeah,
Yeah,
we won't get into those details, but basically, like if you've ever wondered how people make this leap from algebraic number theory and some aspects of analytic number theory in class field theory to like the automorphic realm, it's basically by number theoretically going to the Adels. So the Adels are quite important, but they're not. I mean, you kind of get comfortable just dealing with equations over the Adels. Like Łukasz and I, we see them all the time. But it occurred to me like the Adels are very different from like Q. And so, part of what we're trying to do is to use it's like to create visualizations to help kind of explain like what's actually happening. And so we were discussing like how could we actually visualize the Adels, and Łukasz had some idea before with like Cantor sets and things, but then he surprised me with this. So
this is simpler. I still want to do Cantor sets, but I started doing Cantor sets and realized if you have like we're like 8,000 or 8,000 already. So if you have like 8,000 of these pieces in Cantor set, you're not gonna see like 16 million of the second order pieces and so on. So like there's only like the first order that matters on this scale if you look at the atlas. I still want to do Cantor sets and show maybe for first 10 primes or something like that. So to be visible.
So okay, so this line we're looking at, these are just the primes, right?
Yeah, these are just the primes. These are just finite fields for different primes. So, and we do like basic arithmetic on p-adic numbers or adels. Like it respects this first digit. It's always as in the arithmetic infinite field.
Hmm.
Like, not maybe the whole arithmetic, but if you, for example, divide, right? You divide numbers, then it's like a division infinite field. Yeah.
So what's this manipulate function do? By the way,
Okay, so
I know
yeah.
Łukasz and I have chatted about all this. I'm just being Socratic for the sake of the conversation.
Yeah, so this is really what's behind adels. You have all these details here, all these higher order terms for each prime. This picture they wouldn't be visible anyway. So. Okay, so this is just a constant integer. And yeah, that's basically how the constant integer look over adels or over the product of finite fields. Over adels, there's this detail here because all these, let's say, vertical lines, the Cantor sets. Here are just the discrete set of first order terms. Yeah. And there is an interesting structure appearing.
So just so people understand, Łukasz, like you drag manipulate, you're manipulating over A.
Over integer. Yeah, so
yeah. So each of these is showing a particular integer in the adel. So if you drag it to 10, it's going to show this is what 10 is in the. Łukasz, if you keep dragging that box, you can just set the size. You can customize the size.
How was it? Do you remember? 1,000?
Yeah.
So now you see
can pick
yeah, basically an integer embedded into these consecutive prime fields, bigger and bigger prime fields.
So this is 5,430 in the adel. This is what an integer looks like. Yeah.
That's what it looks like in first order adels. Yeah, but as the slopes of this line becomes steeper and steeper, see interesting structure appearing. Where is it? No, no. Oh, like for example here. Because once in the wires, there are like these parabolas appearing.
I think we have to make the animation rate slightly slower, right? I think we made it 10,000, just for the sake of trying to move through it quickly. But I think before it was slower. Maybe it was like one. It was 1,000, maybe.
Well, hold on. Can you explain what the parabola is there?
What?
Do we know? I mean, we have some guesses, but
Or maybe start with just the slope. So like take any monotonic slope and try to explain why it's there. What is actually happening? What is mod? What kind of number it shows? And why modding it results in this thing?
Like this is like one number, one particular number with increases. Sure. But this is just a number, integer number, modulo consecutive primes.
So it doesn't have to be a
Right?
prime, right?
Yeah, it doesn't. Here
So,
you don't have primes, but you have all the
so
numbers.
just a residue versus the actual number.
Yeah,
Something
and
like
you have these funny parabolas. Yeah, I think they come as an integral of this slope. I think that's the reason. Do I expect to see like higher order curves? Because it started with straight lines. Now it's parabolas. And
What do you mean integral of the slope though? Why would that appear in the
because you I haven't had that much time to think about it.
yeah.
But it's pretty recent.
But this is a good example of like, we've mostly thought of the Adels just as this, really just as this symbol, the symbol with a definition. Um, Obviously, it has structure, and evidently, it even has kind of dynamics when you kind of probe over it. And so, this is kind of a good example of what we're trying to do with this project, which is it might seem naive at first, like, you know, we're not doing math formalization, and we're not creating a like the Xena project, but we're not really creating a database like LMFDB. Instead, we're just kind of probing these concepts and trying to use computers as a formal way to visualize and probe them in order to, one, test our own understanding of them, and also, also refine our and verify our understanding of them, but also to find properties like these that either highlight something that we don't understand about them yet, or I don't know. I don't want to be arrogant, but maybe we can even find things that aspects of some of these concepts that are usually not studied. Now, they could be trivial, they could be unimportant, even if they seem visually interesting. But yeah, moving very slowly. Łukasz, you can specify the size in the code. And then you don't have to do drag anymore. Okay.
Okay, let's see if now we're gonna have third order curves.
Okay.
obviously.
I didn't see any.
How much? Yeah, let's leave it like that.
Why make it so fast?
Let's see. Parabolas.
Are you wondering if third order terms are going to emerge out of this?
Yeah, but like, okay, whatever. At this point, I think the point is that this is a motivation for adults, basically. All these graphs, things for different prime fields, and you can refine and take higher order terms, and you have like what 106. Yeah, and if we start. If you start with an integer,
Yeah.
that noise becomes constant at some point, of course, and you can really think of real numbers as a limiting case of this, as it goes to infinity. This prime goes to infinity, then the real numbers, or maybe integers become this infinite prime.
Nestorovia.
Okay, but here we have some other things, namely division. This is the grandfather of all the reciprocity laws.
You might have to explain that to the
Yeah,
folks at home.
Division. Nice pictures. Oh, what is this? No. Okay. Yeah, so this is one half. So if you, one half is one of these fields, and if you go to infinite prime, then one half is basically half of the infinity, something like that. It's always yeah. One third is more interesting because really there are one third or two thirds depending on the equivalence class mod 3. Called something like that. But like 1/5, 2/5, 3/5, and 4/5. And in what class your number are depends on
Hey,
your number mod 5.
Nick, are you following this? Does this make any sense to you? Nick is like our ambassador to the rest of the world.
I'm better at writing. That's good.
Yes, well, me too.
I can just write again and again. Think if everything is clear when I speak, it's just one big case.
Nick, can you understand that Polish that Łukasz has written down there?
No. Well, at least the plot is kind of clear.
Yeah.
This plot is well, reasonable. You have mod 5, so at least it's like
Yeah,
repetition
but
of 5.
you're
Not mod
really
5.
modding.
Yeah.
Yeah, mod n.
5 itself.
It
Yeah.
is you're modding 1/5 mod n,
Yeah.
and in which class of this your number is depends on the number of n mod 5. It's like
Yes.
we solve this, right? You solve something mod n, and the solution depends on n mod 5. This is like the
So
grandfather
hold
of
on. Mod
reciprocity.
inverse is the same as basically power your integer power to -1 mod n, right?
Mm-hmm. Yeah.
Why do you use your own function? I think you can have it. You have a
I use
function
what?
for that. Maybe power mod. Yeah, you can use power
Yeah, I
mod.
think
It's 5 minus 1, right?
yeah, but it's it should be
Power mod is
power mod 5.
you need different argument. Yeah.
5 minus 1 mod
Oh, I.
n.
Okay.
Yeah, it should be the same, right?
Yeah.
Now, by the way,
There's
Łukasz, like, if you look at some of those, well, if you look at those Adele plots, maybe like the one you have below, the larger one. Yeah, that one. So, so you know how, so Dirichlet has this theorem that there'll be an infinite number of primes
Yeah.
in each congruence class,
Mhm.
right?
Because
And yeah, and
here
this
I have
kind of
all the numbers.
this kind of shows that, right?
Yeah, here are all the numbers. But yeah, of course, you have this homogeneity in different classes, but here you have primes, and it looks pretty chaotic, but in the limit, it should be like equal amount of primes in each class.
Right. So even like Dirichlet was not working in an adelic setting, but we could still appreciate some of those works. Yeah, in this setting. Yeah. Uh-oh.
Come on, look at it. Okay.
It would be nice if Mathematica had some setting where they basically say like, I can make this graphic if you really want it, but it's probably gonna mess up your front end. I'd love like a warning like that. Nick, do you think that's possible? Like in principle?
front end is a hellhole. Yeah, I would really want the front end to have like a simple button to kill it, you know? Just don't touch my kernel, kill the front end, restart it. Keep my kernel normal. So yeah, it can get really laggy. By the way, can you check my voice on stream? We have a comment that I'm silent for some reason, even though I'm pretty sure.
Christ.
I'm pretty sure.
We had a stream without like video, then we don't have a stream without.
No, only me, not
So-
like not everybody else.
Hold on. Okay. No, I hear you. I hear you, Nick. I hear you.
For the YouTube, right? Not Zoom.
Oh no, I know on Twitch. I
No,
heard you on Twitch.
Well, it should be okay on YouTube.
Yeah.
So just
For the person who didn't hear Nick, maybe make sure your audio is working in general. If you do have further problems, let us know.
I don't know, maybe it didn't work. Well, it looked like it was working. My mic this status jumping around. So I don't know. Yeah.
It says 64 though. 64.
Well, I mean, to conclude this, like, I don't know. So, Lukasz, what else in the Adelic world, you think is worth visualizing? You think we could visualize Adele class groups, where you basically take the Adeles and then you mod it out by another group? It should be possible in principle, right?
Mm-hmm. Yeah, like the classes of these paths. Like, so we're gonna have a. How would you visualize modding R squared by R? You can just take. Yep. Like in this case, it could squeeze, but it's not obvious how to squeeze in this case. So you can just consider like all the, let's say, vertical lines, and you act on whole sets, right? So you could do something similar here. Because like 1 point, one Adele is the path to this space. So we're gonna have some set of paths, actually all in the equivalence class. And yeah, maybe something like that. Yeah, yeah, and another thing I do is I think I'll normalize the height of this. So this is everything. This is like horizontal line, and then you could really see this counter set structure in each of these lines, and as it becomes more and more dense and less important. But yeah, but then every integer will go to 0 in the limit. But, yeah, that's what we need to deal with. Yeah, if I normalize unbounded primes to 1, the integer is collapse.
Oh yeah, I had one. It's a very small question. If you go
Oh, this
back,
I forgot about this. Yeah.
just a quick question about if you scroll down to the plot below,
Mhm.
the one actually the one below that one. Yeah. Sometimes it looks like the blue plot is actually like dipping below the horizontal axis, but that's just like a visual
Mhm. Mhm.
bug. They don't they don't go farther
Yeah,
down than 0,
can I stop
right?
it from connecting these lines without going on half an hour straight into documentation?
Well, isn't this the problem you had with the other the other thing?
Because I want it to look like that all the time.
You want it to look like this? Well, why don't you
Yeah,
just make it why don't you just make it a list plot instead of a
just do it. Yeah, this plot.
Well,
No,
it's not gonna work. You have to make an
yeah. I
explicit
need
list,
to
like make a table or something.
wait on
Just
this.
don't forget evaluate again.
This well, What? Now table of what exactly? Okay, so it is less than 1, 2, 3. Okay.
We're just going to table over n, right?
Mm-hmm. Table 1 squared maybe. From 1 to
We already have it. Yeah.
Oh, why is it red?
No evaluate.
Oh yeah, I know. I used it at the beginning, but it has some problems when your modular inverse. Like not here, but it has problems here. Basically,
Oh,
when I used it
what?
for this, the modular inverse might not always exist. So in this case, yeah.
Well, but there's another thing. If you go down, what about the A's are just kind of shouldn't those A's be included in the well, I don't know.
If you go to help, there's like a button that you can say why pink, and it will say why it's pink.
Where?
The help, in the file menu above for Mathematica. You go help.
File?
No, the last one, the help one.
Help. Okay.
Yeah, and there's like
And what?
why pink or something like that.
Why the
It
beep?
doesn't say
Why
why
the
pink.
coloring?
Why the
Why
coloring?
the
Why the coloring and why the beep there? In this case, it's why the coloring.
No
Maybe.
syntax coloring detected.
Oh, it's only a syntax coloring. Yeah, I guess.
Well, look, I mean, I don't know. Dare we click that red box with the ellipses in the upper right-hand corner?
Indeterminate expression. Oh, because
Yeah.
I guess I want this. Oh, mod 0. Right. So this is mod 0. And from 1. Now. Okay. Yeah, I mentioned white noise.
Yeah. So we don't understand where the parabolas come from. There's no sign of higher order. There's no uh, hyperbolas or anything. Um, well, is there anything else?
We have the whole Chebotarev of density.
Yeah. Are we gonna? Should we explain? Should we try and explain it to people?
Like,
Or
maybe next
alternatively,
time. Maybe
yeah. Nick, is there
because
anything you want to show? We still
it
have
will take a while.
still have maybe a little bit of
No,
time.
I don't think I have something new. The hypergraph department to show. Well, I republished that page official into the Parklet repository with a nicer picture with our hypergraph rendering, so you can check that out.
Is that the update? The update is that the Packlet repository page is a different.
Well, I also changed a bunch of documentation. There are like more docs because most of the pages were empty there. At least I filled it a little bit. So you can click around, you'll see at least a single example everywhere.
Yeah, and I don't know. I mean, for those who don't know, we like the work that we do, we're not producing code or functionality that goes into like software updates that say Wolfram Research publishes, because we're not making proprietary software for a company. But instead, what we do is, if we have code that we think other people might use, we upload them to these public repositories where it has documentation, it has examples, but it also has source notebooks, so you can go in and you can see how exactly the functions were made. So if you go to the function repository, you can get a source notebook, and you can actually see what was involved in making those functions. Now, technically, they'll be made of a bunch of other Wolfram language functions, and you don't know what's inside of those. So, but you can still see the Wolfram language functions and code that is used to make these new functions. And sometimes when there's like a family of functions that are kind of related, Nick especially uploads them as these packlets. And so anyway, I mean, one nice thing about the repositories that we sometimes take advantage of is because these source notebooks are just open, you could take the function and you could play with it slightly, and you could kind of modify it for your own purposes. So Rohan, for instance, did that with some PetriNet functionality. And so anyway, so if you like what we do and you want our code, I mean, if you need something urgently, you could always just ask on Discord, like, hey, that Adele thing looks nice. I'm doing my PhD thesis on British pop singers, and I desperately need that plot. Can I use it? And yeah, it would be fine. But if you know, so if you ever need something desperately, just let us know. But in general, we try and make these things available publicly. But if it's like, okay, you know, this function that Łukasz made is nice, but I want it to be list plot, or want it to be this, or want it to be that, you can technically change it, because the kind of like the actual code used to make the functions will be available, so you can use that kind of thing. Anyway, that's just for people who don't know what Nick is talking about with Packlet repository. That's basically what it is. So the hypergraph functionality we were looking at on Wednesday, you should be able to access it and use it, but you can also toy with it and play with it. You can make it better, you can make it worse, whatever you want to do. I don't know why you would want to make it worse, but it's not me to judge. Well, this roundtable had this was basically just Łukasz's non-Archimedean show and tell in the end. But I have seen everything that he showed already, but I'm happy to see it again. So next week, we'll have another one of these with Carlos and Richard, who are both more talkative usually than Łukasz and Nick. So it's somewhat of an introverted meeting, just with just the three of us. So anyway, Richard and Carlos will be back next week. We'll have another one of these roundtables, and we'll speak about the research that we're doing in greater detail. Also, this work that Łukasz was showing, in part, we're taking some of these examples and we're assembling them into our research review, and that reviews the work that everyone at the Institute is doing, and that will become available soon. So stay tuned for that. And if if you're interested in it, or you want a signed copy or something, just kidding. But if you're interested in it, we'll be happy to send it to you when it's ready. All right, everyone. Well, the time went by kind of quickly, but Łukasz, thanks for sharing. And Nick, thanks for streaming. So far as I'm aware, the stream didn't fail. I think I'm looking on Twitch. I'm looking at myself speaking with a lag, which is kind of looking at myself mirror flipped, speaking with a lag. It's not kind of disturbing. So stopped looking at it. But yeah, it seems as though the stream didn't fail this time, so that's good. So yeah, any last thoughts, prayers, haikus?
I don't think so.
All right, everyone. See you next week. Thanks for watching. Cheers.